In this section, I'll talk about the inverse trigonometric functions and their derivatives. We'll start with a quick refresher on what inverse trigonometric functions are and how they are defined. So let's start out with a bit of a bold statement. None of the 6 basic trigonometric functions has an inverse. This statement is technically true because all 6 trigonometric functions are periodic and therefore are not one-to-one, which is a requirement for a function to have an inverse. So in order to define an inverse of a basic trigonometric function, we have to restrict the domain of it. There are many ways to restrict the domain for the sine function, but the standard choice is to restrict the domain from negative pi over 2 to pi over 2. So we have that the restricted domain is negative pi over 2 to pi over 2. Because if we restrict the domain to those values, then the sine function takes on all its values, all its possible values from negative 1 to 1. So for the sine, when we look at the sine and we look at the domain versus the range, we see that the domain, the restricted domain, is negative pi over 2 to pi over 2. And the range is negative 1 to 1. And now that function is 1 to 1. And so if we look at the inverse sine or the arc sine, then the range and the domain flip. So for the arc sine, the domain is negative 1 to 1, and the range for the arc sine is negative pi over 2 to pi over 2. So we can do that for all the 6 basic trigonometric functions: the sine, the cosine, the tangent, the cotangent, the secant, and the cosecant. And so what you see here is what I talked about, that the domain of the arc sine is negative 1 to 1, and the range is negative pi over 2 to pi over 2. Now, let me briefly talk about the arctangent, and I will not talk about all 6 of them, but just to see where the arctangent comes from. And hopefully you recall that when you look at the graph of the arctangent, or sorry, the graph of the tangent, that the graph of the tangent has 2 vertical asymptotes. So the 2 asymptotes for the tangent are at pi over 2 and at negative pi over 2. And then the tangent runs between those 2 asymptotes, and then it repeats. So when you look at the domain of the tangent runs from negative pi over 2 to pi over 2, but because the asymptotes are not included, it's less than and not greater than or equal. So that domain of the tangent is negative pi over 2, negative pi over 2 not included, to pi over 2. That turns into the range of the arctan. And because the range of the tangent is all real numbers, because it blows up, the range of the tangent is negative infinity to infinity, and therefore the domain of the arctangent is all real numbers. So, and you can do similar things for all the other basic trigonometric functions. So let's take a look and evaluate the arcsine of negative 1/2. So let's use the definition here. And we see that the definition tells us that y equals arcsine of x if and only if sine of y equals x. So let's give this expression a name. Y equals arcsine of negative 1/2. By definition, this is the same as sine of y equals negative 1/2. Now, you can memorize this definition. You can also think of it as, well, sine and arcsine are each other's inverses. So what I can do here is I could take sine on both sides and then take sine of y equals sine of arcsine of negative 1/2. And since the sine and the arcsine are inverses, they cancel each other out. And then we're left with sine y equals negative 1/2. So that's kind of maybe an easier way to memorize this and to memorize this definition here. To get y, we would take the sine on both sides, and now we have sine of y equals negative 1/2. And so now we have a problem though, because sine is periodic, and so it has infinitely many solutions. Now, if you look at the unit circle and you want to figure out where sine of y equals negative 1/2, on the unit circle, the y coordinate is the sine. So if I look at this line, right, at negative 1/2, that means that I have two potential angles, right? I have this one right here and this one right here, for which sine of y equals negative 1/2. Now, we do know that the restricted domain of the sine is negative pi over 2 to pi over 2. So basically, the arcsine only lives on this side of the unit circle. So this side from negative pi over 2 to pi over 2, that's where the arcsine lives. Arcsine lives here. And if you know your unit circle, you can then see that this value right here corresponds with negative pi over 6. So because we know that y has to be between negative pi over 2 and pi over 2, we now know that our answer in this part right here, we have that y equals negative pi over 6. And that is our final answer. Let's do another one. We want to find y equals arctan of square root of 3. And then we take the tangent on both sides. So we get tan of y on the left, and the tan of the arctan, they cancel each other out. And so we're looking for a value for which tangent of y is square root of 3. And we know that y has to be between pi over 2, less than pi over 2, but more than negative pi over 2. So again, this is something that you can look up in a unit circle, but let me give you kind of a way to cheat here, or kind of use technology as a shortcut here. So on the TI-84, you can set your calculator to degrees. And the way you do that is you click on mode. So, and typically you always want to have your calculator in radians when you work with in calculus, but in order to kind of figure out what these values are, you can set your calculator to degrees. You go to mode, and then you select degree. There are two options there for most TI-84s. So you go mode, and then you select degree instead of radians. And now what you can do is you can go back, and now you can do second. We can go straight to the answer. We do second, and then the tan button for tangent. And because we use second tan, that will do the tan inverse. And so if you put that into your calculator, tan inverse of square root of 3, that will give you 60. So now we do square root of 3. And that will give you y equals 60 degrees. Now our final answer should be in radians, so we can convert from degrees to radians as follows. So if we go degrees and we have to go to radians, then we have to multiply by pi over 180. Because 180 degrees is pi radians. So if you multiply by pi over 180, you get your final answer in radians. So we take that 60 degrees and we multiply that by pi over 180, and then our final answer for y is pi over 3.